There's a couple of ways you can tackle this. The way my brain is telling me to do it is to get the Cartesian equation. I find it difficult to understand what's going on when we're working in parameters, especially when we're talking about this tangent line that is in Cartesian form, meeting the curve again. So if we had this curve in Cartesian form, that would be really easy. So what we can do is make t the subject of this equation here, really quite straightforwardly, just by bringing the t up here and the y back down here. So t is the same as 1 over y, which I can then substitute into here to get this relatively straightforward Cartesian equation. So this is the Cartesian equation that we're dealing with, and we want to know, we know that it meets once at 4 minus a half, that this line here meets this curve here at 4 negative a half. We want to know the other place it meets it at. So we're going to solve these simultaneous equations. So we've got we can write down that x equals 12 plus 16y. X also equals this, so we can then say that 1 over y squared equals 12 plus 16y. And we have to solve that. It's a bit of a pain. We're going to have 1 equals 12y squared plus 16y cubed. Now, initially it looks like we're going to have to solve this cubic, but we already know one solution. We know that a solution is that y can be negative a half. So if I rearrange this into 16y cubed plus 12y squared, take 1 equals 0, then I know that one of the factors, or one of the solutions, is that y equals negative a half. Or in other words, a root of that would be that 2y plus 1 is a factor. Because if that equals 0, if that was one of my brackets that equals 0, I take 1 away and divide by 2. So that's one of my brackets. So we know that, sorry, that should be a cube there. We know that 16y cubed plus 12y squared, take away 1, can be written as 2y plus 1 times by some quadratic. The quadratic, we're only going to have to work out the middle term. The first term must be an 8y squared, because that's the only way we're going to get a 16y cubed. And the end term must be negative 1, because plus 1 times minus 1 gives us our minus 1. The only thing we don't know is how many y's we've got in the middle. So if we then compare coefficients of the left-hand side and the right-hand side, so I could compare coefficients of y squared or of y, doesn't matter. Let's go for y squared because we can see on the left-hand side it's 12. If we compare coefficients of y squared, we get 12 on the left. On the right hand side we get an 8 there, and we get a 2a there. So that tells me that 2a is 4, and therefore a must be 2. So now we can go back up to wherever we had it here and say that 16y cubed plus 12y squared take away 1 could be written as 2y plus 1 times by 8y squared plus 2y take 1. Then we need to find a solution to this, which you can either do by trying to factorise it or completing the square or using the formula. It will factorise. Okay, it will factorise. I'm going to have a plus 1 and a minus 1. I'm going to have a 4y and a 2y. I want positive 2y, so if I had positive 4y and take away 2y, that will give me plus 2y. You can see here we've got a repeated root, so the 2y plus 1 has appeared twice, but the one we're after, the one that's important to us, is this 4y take away 1, which tells me that the other solution is when y equals a quarter. And all we then have to do is work out what t value that, or well, a couple of things we could do actually. Work out what t value that corresponds to, or go back to the Cartesian equation, which we had here, or go back to the tangent line equation, which we had here, and substitute that y equals a quarter in. I'm going to go for this one here. And say that when y is a quarter, x is 12 plus a quarter of 16, which is 4, so x is 16. So the value of the, oh, it wants the value of the parameter. Oh, right, sorry. So we do need to use the t. T is 1 over y, so ignore all that red stuff. We've got that y is a quarter, and when y equals a quarter, t is 1 over y, so 1 over a quarter, so t was 4.